Hello everybody, welcome to the homework help video for 522. I'll be going over problems 65 through 70. So in problem 65, it tells us to determine whether 447 is a term of each sequence below, and if so, what term is it? So what's going to be really helpful for you guys is understanding that sequences are discrete. What that means is that when we're solving for n later, we want to be solving for whole positive numbers. If we get anything that's negative or not a whole number, so if it has a decimal or a fraction answer, it will not be a solution. So let's begin with A. So for all of these, what we're interested in doing is setting it equal to 447. And in part A, we'd set 447 equal to 5n minus 3, and then we just solve for n. So we're going to add 3 to both sides. We're looking at 450 is equal to 5n, and I know that when I divide 450 by 5, we're going to get a whole number, and we're going to get that n is equal to 90. So for A is a possible solution. Or, sorry, there is a term, and it's term 90. So n is equal to 90. Let's try B. In B, again, we'll still have 447 is now equal to 24 minus 5n. So this time we're going to subtract 4n from, or 24 from both sides. 447 minus 24. It's going to give us 423 is equal to negative 5n. So something is going to happen here. We're going to divide both sides by negative 5, and that's going to give us two things that cannot happen. We're going to get that n is equal to negative 84.6. So two things that are really bad that tell us that this is not, there's no possible n for this, is that it is both negative and has a fraction. So if something is truly a sequence, we know that our domain has to be all whole numbers. And so if we had 84 or 85, it would work. But because we've got a negative and a decimal, it does not work. We were still able to solve for an answer. So please don't make the mistake of thinking just because you can get a number means it solves it. That is not the case for sequences. All right, since we got one that works and one doesn't, let's do one more. Let's look at E together. So for E, again, 447 is equal to negative 8 minus 7 times the quantity n minus 1. So I'm going to work on my order of operations. I cannot do negative 8 minus 7. That would not follow order of operations. First thing I'm going to do is add 8 to both sides. So we'll get 447 plus 8, which will be 455, is going to be equal to negative 7 times n minus 1. Then I'm going to take and divide both sides by negative 7. 455 divided by negative 7. We've got that negative 65 is equal to n minus 1. And when we add 1 to both sides, we get that negative 64 is equal to n. So one of the things that we got that we wanted is a whole number. However, 64 is negative and therefore is not an answer because of that negative sign. All right. So let's move on to 66, which is going to involve 65. It says to choose one of the sequences from 65 for which you determine that 447 is not a term. Write a clear explanation describing how you can be sure that it is not a term of the sequence. So I'm going to do this right above in this empty space. So I'm going to look at B, because in B it was not an answer. And so we want to write a clear explanation describing how you can be sure. So we already solved it, and what happened is we got a negative and a decimal. So what I'm going to say is that the domain for all sequences must be whole numbers. in B, we saw that the answer was was a negative and a decimal. So our answer was that n was equal to, I believe it was negative 84.6, which is not in our domain. And that's a clear explanation of why it cannot work. Talking about how our domain has to be those whole positive numbers. All right. So if you want to, you can pause the video and finish writing that down. I'm going to go ahead and move on to 67. So I'm going to scroll down and then erase. Ooh. Come on. All right. So in 67, it wants us to find the sequence generator for each sequence listed below, and to write an equation for the nth term in each sequence. So we need the generator, and we also need the equation. So in A, I'm going to look at 4. So we go 4, then 7, then 3, 4, 7, 10. And so you can see that what we're doing each time is we are adding 3. So our generator is positive 3. And I want to make sure to include that operation. We're adding 3 each time. So when I think of my function, the notation we're using is that t of n is equal to. So what happens is that for all of these, our generator, or our common difference, is going to become the slope. It's going to become the multiplier. So we'll have 3n, and then we're going to need to figure out what our 0 term would be. To do that, I knew that I needed to add 3 both times, so to go backwards, I'm going to subtract 3, which will give me 1. So our answer for A is 3n plus 1. And we can go back and double check our work. I'll pick a random one. So here, this is my third term. 10 is my third term. So when I plug in 3, t of 3 should be equal to 10. So we'll do 3 times 3, oops, 3 times 3 plus 1, which will give us 9 plus 1, which is equal to 10. So that'll check out for us. So again, our generator is plus 3, and the equation is t of n is equal to 3n plus 1. Let's do one more together. Let's look at one that is decreasing. So in C, it looks like we're going down because the first observation we make, we went from 24 to 19, from 19 to 14. And so as we move on to the next term, each time we are subtracting 5. And so our generator is going to become subtract 5, or take away 5. And we want to put this into our equation for t of n is equal to, and again, remember our generator is our multiplier, so negative 5 times n, and then we need to figure out our starting value. So we'll go back. So before we would subtract 5, this time we will add 5, and then 24 plus 5 is 29. So our starting value in our equation is 20. Again, you should be able to check your work and see that it all works out. All right, we'll move on to 68. In 68, it says that the Great Amusement Park has been raising ticket prices every year, as shown in the table below. In A, they want us to describe how our ticket prices are growing, and what will the price of admission be in year 6. All right, so with this problem, when we look at it, it's pretty clear that we don't have anything arithmetic, nothing linear. We go from 0 to 1, we went up by 5. From 1 to 2, we went up by $5.50. and then we went up by $6.05. And so we can see that it's really clear that we don't have anything arithmetic. We're not going up by a constant. What they wanted you to realize is that this time we have a geometric series. I know we haven't talked about this one too much, but it's actually very similar to when we were working with the bouncy ball. We came up with those ratios, and what we would do is we would take the next one in the series, so looking at 1, and then we would divide it by what came before. So we're going to do that. We're going to take 55 is our new cost, and we're going to divide it by our previous cost. That's going to give me 55 divided by 50 should be 1.1. We can check that with the other one, so we should have this constant rate if it is geometric. So in the next one, I'm going to take 60.5 and divide it by 55. When I do that, I again get 1.1. So our generator, or how we're growing, is we're multiplying by 1.1. Multiplying by 1.1. Multiplying by 1.1. And then what will it be in year 6? Well, we can just do that multiplication 3 more times. Or, if we want to, we could even use an equation. So if I go to my graphing calculator, go to my y equals, and to clear out a few of my equations. Don't freeze, don't freeze. Sorry, my calculator is freezing on me. There we go. So we'll clear out the 2 equations that are there before. And then if we wrote our new equation, we would take our starting value. So how much were the tickets to begin with? I believe it was $50. Yes. It was $50. So we take our starting value, our 50, and then we multiply it by 1.1. That was our generator, or our pattern, to the x. I will then go to my table and look for the 6th value. So I need to scroll down just a little bit. And so we can see in year 6, ticket prices will be $88.58. All right. So again, our answer for B was $88.58. For 69, it wants us to solve the system below for M and for B. So we're doing our systems of equations. With the way it's set up, it looks like our best bet is to do elimination. So I'm going to solve using elimination. I look and I see that my B's both have the same coefficient of +1. What I'm going to do then is I'm going to take and multiply my bottom equation by -1 and rewrite them. So we'll have 1239 is equal to 94m plus b over -810 is equal to -61m minus b. I can now take and add those together. I'm going to write it in the space below those sentences. So 1239 minus 810 is 429 is now equal to 94 minus 61, which is 33m, and our b's have canceled out. So from there, we're just solving for m, dividing both sides by our 33. So 429 divided by 33, m is equal to 13, and now we just need to figure out what b is going to be equal to. So I'm going to take my 13, and I'm just going to plug it into one of my original equations. So for this one, I think I'll use the top equation, and so I'm going to plug in 13 for m. When I do that, we've got 1239 is equal to 94 times 33 plus b. So 3,102 plus b. Subtract. So B is going to be equal to negative 1,860. Negative 1,860. And that's our answer for 69. We have one more left for number 70. So I've got that one scrolled down. I'm going to need to erase this work. So if you need to, you can pause it, pause the video, and write it down. All right, lastly in 70, we've got a word problem. It tells us that the French Club sold rose bouquets and chocolate hearts for Valentine's Day. The roses sold for $5 and the hearts sold for $3. But the number of bouquets sold was 15 more than the number of hearts sold. If the club collected $339, how many gifts of each were sold? All right, so the first thing we want to do is define our variables. Looks like we're going to be talking about rose bouquets, so I'm going to call that R is equal to the number of rose bouquets. I'm going to say number of roses. And then C is equal to the number of chocolate hearts we sold. I believe they said it was chocolate hearts. Yes. Then I want to start putting together some equations. The first one I'm going to do is my equation for the amount of money that they made. I know that they made a total of $339. And I know that that's going to come from if they charge $5 for the roses, so 5 times R, plus $3 for every chocolate heart they sold. So that's one of my equations. The next one is they tell me a very important relationship between the number of chocolate hearts versus the number of rose bouquets they sold. They said that the number of bouquets, so the number of bouquets, the number of roses, R, is really saying is, equal to 15 more than the number of hearts. So we've got C plus 15. So we've created a system of equations that we can solve. Here, our method that we're going to want to use is substitution, because we've already got one of them solved for a variable. We've got an R is equal to. So what I'm going to do is take and plug that into my original equation. So 339 is now equal to 5 times C plus 15 plus 3C. When we simplify that, 339 is equal to 5C plus, let's see, I believe it should be 100 something. 15 times 5 is, 225. Oh, that's times 45. That put wrong numbers in my calculator. 15 times 5 is 75. So plus 75 plus 3C. I'm next going to combine my like terms. So I've got a 5C and a 3C. That's going to combine to 8C. I'm going to rewrite this. 339 is equal to 8C plus 75. So I'll take and subtract 75 from both sides. 339 minus 75, 264 is equal to 8C. Dividing both sides by 8. I know that my number of chocolate hearts is 33. So we sold 33 total. And then I can take and plug that back in to one of my original equations. So I'm going to use the one where we solve for R. We said that R is equal to C plus 15. I know that C is equal to 33, so 33 plus 15 is equal to 48. So we sold 48 bouquets of roses. And that'll do it for your homework.